In this video, we'll look at the one proportion z-test. The purpose of this test is to test the specific claim about a population proportion, H naught, that is, a population proportion P is equal to some specific value P naught. This is going to be our working assumption in everything that follows. And in order to do this test, we're going to need to use the sampling distribution for P hat, the sample proportion that we get from our data. And the conditions for that sampling distribution are we have to have a simple random sample, a population at least 10 times the sample size, and the expected number of successes and failures in the sample are both at least 10. Now you notice here we have P naught, that specific value that comes from the null hypothesis, goes in there along with the specific size of our sample when we check that third condition. So we have to expect at least 10 successes and 10 failures in our sample. And this will make this sampling distribution of P hat approximately normal. Okay, so that's the first instance of where this became a working assumption that affected the work that we did later on down the line. Now the formula for the test statistic, it's a z-statistic, is P hat, the sample proportion, minus P naught, which is the mean of the sampling distribution of P hat, if H naught is true, divided by the standard deviation of P hat, which is the square root of P naught times 1 minus P naught over n. Again, assuming that the null hypothesis is true. So that's the second example of where the null hypothesis mattered as a working assumption. If you want to conduct this test on the calculator, you go to Stat Tests and select number 5, one proportion z-test from the list, and I'll show you how that gets done in a little bit. So let's look at an example. During the week of October 6th, 41% of U.S. adults approved of the President's job performance. During the week of December 29th, 1,170 people in a random sample of 2,543 U.S. adults say they approve of the job the President is doing. Do these data provide evidence that the President's approval rating has gone up significantly at an alpha level of 0.05? So we'll select that level of significance. The sample proportion P hat is just the number of successes in the sample, 1,170 divided by the sample size, 2,543. And that's about 0.46. We want to see if this 0.46 is significantly above that 0.41 or 41% that we had back in October. Our null hypothesis is going to be that there is no change. The null hypothesis is that P is equal to 0.41. That is 41% of U.S. adults approve of the President's job performance, versus the alternative that P is greater than 0.41. That means more than 41% of U.S. adults approve of the President's job performance. The test we're going to conduct is a one proportion z-test. We need to use the sampling distribution for P hat in order to do this test, so we have to check the conditions. We're given a random sample, so the randomization condition is met. The population of U.S. adults is much larger than 10 times the sample size, so that independence condition is met. And then if we plug in n and P naught from the null hypothesis in here, we get 1,042.63 expected successes in our sample. That's much bigger than 10. And the expected number of failures in the sample is about 1,500.37, which is also much greater than 10. So the conditions are met. We have a randomization condition met. The sample observations are approximately independent, and the sampling distribution of P hat is approximately normal based on the success-failure condition. Now, when we conduct this test, we have to calculate a test statistic. This is the formula you saw before. P hat minus P naught over the square root of P naught times 1 minus P naught over n. Plug in everything. P hat is 1,170 over 2,543. P naught is 0.41. It goes here, here, and here. And then the sample size is 2,543. When we simplify that expression, we get 5.1354. This z-statistic is a standard normal random variable. It has a mean of 0 and a standard deviation of 1. So you can use your z-distribution and your normal CDF on your calculator to find the probability that z takes a value that's greater than 5.1354. Here's the picture of that situation. Here's your z distribution with the mean of 0. 5.1354 is way over here. It's 5.1354 standard deviations above 0. And here's the tail. That's the p-value for this test. It's very, very small. Works out to be 1.4 times 10 to the minus 7th. Now we compare that p-value to our alpha level, and you see the p-value is much smaller than the alpha level. So what we've got basically is a sample statistic, p-hat is 0.46, and a test statistic, 5.1354, that are both very rare if the null hypothesis is true. And since they're much more rare than 5 out of 100 or 1 in 20, we reject the null hypothesis. So our conclusion will be that we reject the null hypothesis that 41% of U.S. adults approve of the president's job performance and find evidence that more than 41% of U.S. adults improve. If you're asked what this p-value means right here, always think of it in terms of like what fraction or proportion of all samples could you take of this size from this population. And this is the probability of getting a sample that gives you a test statistic that's bigger than that right there. So when you're asked to interpret the p-value, say something like this. The p-value of 1.4 times 10 to the minus 7th means that if the null hypothesis is true, it's a very important thing to put in there, a random sample of this size, 2,543, from this population, all U.S. adults, in which 46% or more of the sample approves of the president's job performance, would occur in about 1.4 samples out of 10 million, or 14 samples in 100 million. It's very, very rare. That's why we rejected the null hypothesis. It's just not a tenable assumption based on how rare our sample results are. Now, if you want to conduct this kind of test on your calculator, it's pretty easy to do. Turn your calculator on and go to Stat Tests, and then select number 5 from this list, and it'll put you into the screen, 1 proportion z-test. Here you're going to put the null hypothesis value, which is 41% or 0.41. Put it in as a decimal. Put in the number of successes in your sample and the number of observations in your sample, so that's your sample size. And then you have to specify what your alternative hypothesis is going to be. In this situation, we're looking for we're using the alternative hypothesis rather, that p is greater than 0.41. So we're going to select this one of the 3 options that are here. And then once you've made all those specifications, you can go to calculate. You see here is our test statistic, 5.1354, etc. This is the p-value right here, 1.4 times 10 to the minus 7th. Here is the p-hat, 0.46, sample size, and that's pretty much all that this test gives you for output. But if you're in a hurry and you need a z-statistic or you need the p-value, you can get it very quickly from this particular place on your calculator. Stat Tests 5.